Hello everyone. So another video of code review. Guys, so in this video I'm going to review two pieces of code. One is vulnerable to cross-site scripting, namely reflected cross-site scripting, and the other is its secured counterpart. So if you wanna if you wanna take a look or see how cross-site scripting looks like during the exploitation, you can go back to my videos. You can go to I think the playlist named Web Application Penetration Testing. You can see many instances. I have explained how it happens. So let's begin, guys, and see how it looks like from the backend. So for the backend, guys, you see there is an input area in a website like form or comment, and you see here the function or the code requires you to input your search or to search for something, to put your comments, whatever it is, you're required to provide that input and to the up to the back end. So the back end over here, guys, you see the name is the input, and after the function or the code takes the input from the user, it immediately passes that for ignore these, it passes that immediately to the function which will print this out. So you see hello get name. The name in this example is your name. It might be your inquiry. It might be a search. It might be comment. So here it prints out the comment immediately or the input immediately to the screen or to the client without any checking. So over here, I typed what would happen if someone decided to break that or to test for cross-site scripting. So instead of the name or instead of the input, you're gonna have a script like that, and instead of that, it's gonna be executed like this. So at the end, you're gonna get hello, and the alert box will show you hello over here. Of course, there are other variations to test for cross-site scripting, but this is how it goes when you don't have input validation for the input the user or the client is providing. So what would happen, guys, in real case scenarios? In real case scenarios, a vulnerable application like that could be exploited by an attacker who would, have kind of um, attacking machine or attacking server. As you can see, the end goal is to steal the user cookies or the current session of the current logged in user. So for example, I have highlighted what would happen over here. So you see, instead of name or instead of the legitimate input, the attacker would type this guys over here. So this one will extract the cookies of the current logged in user, send that to the attacker server, as you can see, evilattacker.com, and it's gonna, store the cookie inside their server, inside a file designated to steal cookies from users. So he's gonna send he's gonna, put that in the comment box or in the search box of the vulnerable app, and then he's gonna end up with a URL. He's gonna send that URL to the logged in user, and once the logged in user clicks on that URL that contains this script over here, their cookies will be definitely sent to the attacker's server. And they're going to be able to log into the user's account without their knowledge, change their password, whatever. So the secret counterpart looks like that. So here, I get the input from the user, and before passing that input, I put some kind of verification. So the function HTML special characters, all it does, guys, it escapes the dangerous characters that could be used or could be encoded into a JavaScript code like this one over here, or this one. So as you can see, there are two functions that can be used in PHP applications to escape data: HTML special characters and HTML entities. So the HTML special characters, guys, as you can see, is going to convert any character among those characters, any character that would appear in the input or in the search box or the comment, is going to convert that or escape it. What does that mean? So the browser will not execute that as a code. It's gonna print it out as a data. So in the secured version, guys, the output. So let's say the output of a malicious query like this. So the attacker will type the script, the browser will print out hello, and then immediately it will print out this without, uh, let me copy that, hello. So that's what will be, what will the output actually will be, guys. What, what the output will be, guys. So the HTML special characters escape these kind of characters when they appear in the input. So the browser or the client will interpret them as data instead of actual code. That's the concept of escaping characters. As we mentioned before, the case of command injection, we escaped dangerous characters that would appear in Linux commands by using the special functions like the I couldn't remember the name, but we walked you through that. I remember. So we can use this guy over here, or we can use the folder variable over here. It will sanitize against all special characters. Okay. So you have two options, guys, to validate and the validate and sanitize the input to prevent against reflected cross-site scripting. In the next video, we're going to talk about stored cross-site scripting, how to detect and review a code for stored cross-site scripting. Actually, it's the same concept. When you work with your applications, all you have to do is to validate the input from the user. It would protect your server from being exploited against a wide range of OWASP vulnerabilities, like uh, SQL injection, command injection. As you can see in the last video, we talked about command injection, and we mentioned that you need to use special functions, PHP functions, to escape dangerous characters, and you also could avoid, the exploitation of XSS, reflected and stored, and other kind of attacks. So I hope you guys found this video somewhat informative, and I hope to see you in the next video.